Every year, more than 4 million tons of dried herbs and spices move through global markets, with a single modern processing plant capable of dehydrating and packaging over 50 tons of fresh herbs daily into products with shelf lives exceeding 2 years. These facilities transform fragrant basil, oregano, thyme, and dozens of other herbs from delicate fresh plants into concentrated flavor powerhouses, removing up to 90% of their water weight while preserving volatile aromatic compounds that give each herb its distinctive character. But how do industrial machines dry herbs without destroying the essential oils that make them valuable? What journey do these plants take from specialized farms to the spice racks in millions of kitchens? And why has the global dried herb market exploded to over $18 billion annually, making it one of the fastest growing segments in food processing? Welcome to AgriCraft, where we explore the real stories behind your food. All will be revealed in this video. The history of dried herbs traces back thousands of years to when ancient civilizations discovered that preserving aromatic plants through drying allowed them to flavor food year-round and provided medicinal remedies long after harvest. Seasons ended. Archaeological evidence shows that Egyptians used dried herbs in cooking, medicine, and religious ceremonies over 5,000 years ago. The spice trade became one of the most economically significant exchanges in human history, with merchants transporting dried herbs and spices along routes connecting Asia, Africa, and Europe. These preserved plants were so valuable that they served as currency, sparked exploration that reshaped world geography, and influenced the rise and fall of empires. While the romantic era of spice caravans and clipper ships has passed, the modern dried herb industry remains globally significant, with production spanning every continent. Today, the dried herb and spice market is valued at approximately $18 billion globally and growing at 6 to 7% annually. India dominates production and export with over 1 million tons of spices and herbs produced yearly, accounting for roughly 40% of global spice trade. Turkey is the leading producer of dried oregano and bay leaves, while Egypt specializes in dried basil and parsley. Mexico produces significant quantities of dried oregano and cilantro. The United States is both a major importer, consuming over 500,000 tons annually, and an emerging producer, with California leading domestic herb cultivation. American agriculture has embraced herb farming, with operations ranging from small organic farms selling direct to consumers to large commercial operations supplying major food processors. The dried herb segment appeals to agri-entrepreneurs because relatively small acreage can generate substantial revenue, with premium dried herbs wholesaling from $10 to $50 per pound compared to traditional crops measured in cents per pound. The journey begins with seed or plant selection because not all herb varieties dry equally well. Breeding programs have developed cultivars specifically chosen for high essential oil content, compact growth habits suitable for mechanical harvesting, disease resistance, and consistent quality. Basil varieties for drying differ from those grown fresh, selected for smaller leaves that dry quickly and concentrated aromatic compounds. Oregano cultivation favors Greek and Mediterranean varieties rich in carvacrol, the compound providing characteristic pungent flavor. Thyme growers choose between common thyme, lemon thyme, and other subspecies based on target markets and flavor profiles. Many herbs are propagated from cuttings rather than seeds to ensure genetic uniformity, with mother plants maintained in greenhouses and cuttings rooted in controlled conditions before field planting. Environmental requirements for herb cultivation are exacting because stressed plants produce poor yields and inferior flavor. Most culinary herbs originated in Mediterranean climates and prefer full sun, well-drained soils, and moderate fertility. Excessive nitrogen produces lush green growth with diluted essential oils, while insufficient nutrients limit yields. Soil pH between 6 and 7 optimizes nutrient availability for most herbs. Water management is critical because drought stress concentrates essential oils, improving flavor but reduces biomass yield, while overwatering dilutes flavors and promotes disease. Many commercial herb farms use drip irrigation, allowing precise water delivery to root zones while keeping foliage dry, reducing fungal disease pressure that plagues herbs grown in humid conditions. Cultivation practices vary by herb species and scale. Annual herbs like basil and cilantro are direct seeded or transplanted into prepared beds in spring, while perennial herbs including oregano, thyme, rosemary, and sage are established from transplants and harvested for multiple years. Spacing is calculated to maximize yield while allowing sufficient air circulation to prevent disease. Weed control is essential because even small amounts of weed contamination in harvested herbs are unacceptable in food processing. Organic operations rely on mulching and hand weeding, while conventional farms may use pre-emergent herbicides applied carefully to avoid herb damage. Pest management addresses aphids, spider mites, and various caterpillars attracted to aromatic foliage. Integrated pest management combines biological controls, including beneficial insects with selective pesticides approved for food crops, always respecting pre-harvest intervals, ensuring no residues remain at harvest. The herbs develop through vegetative growth phases, producing the leafy material harvested for drying. Unlike vegetables or fruits where farmers wait for specific maturity indicators, herb quality peaks just before flowering when essential oil concentrations reach maximum levels. As plants begin flowering, energy diverts from foliage production to reproduction, and essential oil composition changes in ways that may reduce culinary quality. Experienced growers monitor fields closely, watching for the first flower buds to appear and scheduling harvest immediately before significant blooming occurs. Harvest timing also considers weather because herbs must be cut when foliage is dry, ideally in morning after dew has evaporated but before midday heat causes plants to wilt. Wet harvest introduces excessive moisture, requiring longer drying times, and increases disease risk during processing. The harvest window for a given planting might span only a few days, requiring careful planning and adequate labor or equipment to complete cutting quickly. Manual harvesting remains common for small-scale and organic operations, where workers use knives or shears to cut herb stems, gathering bundles that are immediately transferred to shaded collection areas. This hand harvesting allows selective cutting of prime material while leaving damaged or diseased plants, ensuring only quality herbs enter processing. However, labor costs make manual harvest economically challenging for large operations. Mechanical harvesting has advanced dramatically with specialized equipment adapted from forage harvesters. These machines use reciprocating blades or rotary cutters to shear herbs just above ground level, with collection systems gathering cut material onto conveyor belts, feeding into bins or trailing wagons. Modern harvesters can process several acres hourly, dramatically reducing labor requirements and harvest costs. The trade-off is less selectivity as machines harvest everything in their path, including any weeds or damaged plants. Transportation to processing plants must happen quickly because cut herbs begin deteriorating immediately. Enzyme activity continues after harvest, degrading essential oils and causing color changes. Heat buildup in piled herbs accelerates deterioration and can even cause spontaneous combustion in extreme cases. Most processors require delivery within 2 to 4 hours of cutting. The herbs are transported in well-ventilated containers or loose in truck beds, allowing air circulation. Some large operations integrate farming with processing, locating production fields adjacent to processing plants, enabling nearly instantaneous transfer from field to facility, minimizing quality loss. The processing plant is where agriculture meets food processing technology and where fresh herbs transform into shelf-stable products. These facilities operate under strict hygiene standards with controlled access, air filtration systems, and regular sanitation protocols. Upon arrival, fresh herbs undergo initial quality inspection, where trained staff assess color, aroma, moisture content, and absence of contamination. Loads containing excessive stems, weeds, damaged leaves, or off odors may be rejected or discounted. Accepted herbs are weighed and tracked through the facility with batch identification, allowing complete traceability from specific fields through final packages. Cleaning represents the first processing step, removing soil, insects, and any remaining foreign material. The herbs may pass through air cleaning systems where powerful fans blow away dust and light debris while heavier herbs fall through onto collection conveyor belts. Some facilities use water washing with herbs passed through tanks or spray systems where clean water rinses foliage. The washing must be gentle to avoid bruising delicate leaves, typically using cold water to minimize essential oil loss. After washing, Excess surface water is removed using centrifugal dryers similar to giant salad spinners, or by passing herbs through air knives where high-velocity air blasts water from leaves. Any washing adds moisture, requiring longer drying times, so many processors prefer dry cleaning methods when herbs arrive clean from the field. Sorting follows cleaning, with workers or automated systems removing stems, flowers, and discolored or damaged leaves. Premium dried herbs consist primarily of clean leaves, while lower grades may include more stem and broken material. The sorting happens on inspection conveyor belts, where workers stationed along the line manually remove defects, or increasingly through optical sorting machines using cameras and artificial intelligence to identify and remove unwanted material. These automated systems can process tons of herbs hourly with consistency impossible for human sorters, though initial investment costs are substantial. The critical transformation happens in drying systems, where controlled heat and airflow remove moisture while preserving color, flavor, and aroma. The challenge is removing water that makes up 70 to 90% of fresh herb weight down to final moisture contents of 8 to 12%, without destroying heat-sensitive essential oils or causing browning from excessive temperature. Traditional air drying involves hanging herb bundles in ventilated spaces for days or weeks, a method still used for small-scale artisan production but impractical for commercial volumes. Modern commercial drying employs sophisticated industrial machines offering precise environmental control. Belt dryers consist of stainless steel mesh conveyor belts moving through long drying chambers with multiple zones maintaining different temperature and humidity conditions. Fresh herbs are spread in thin layers on the belt at one end, passing through progressively warmer drier zones over 1 to 4 hours before emerging completely dried at the opposite end. Heated air flows through the herb layer from below, above, or both, carrying away moisture. Temperature control is critical, with initial zones operating at relatively low temperatures around 90 to 120 degrees to remove surface moisture without shocking plants. Middle zones increasing to 120 to 150 degrees for bulk drying, and final zones sometimes dropping temperature while continuing airflow to cool herbs before packaging. The multi-zone approach optimizes drying speed while protecting quality. Fluidized bed dryers use powerful fans blowing heated air up through perforated floors, suspending herbs in turbulent airflow that rapidly removes moisture. These systems dry herbs very quickly, sometimes in minutes rather than hours, and work particularly well for small leaf herbs like thyme or oregano. The rapid drying can better preserve color and volatile compounds compared to slower methods, though capital and energy costs are higher. Freeze drying represents the premium technology producing the highest quality dried herbs with superior color, flavor, and rehydration properties. The herbs are frozen and then placed in vacuum chambers where ice sublimates directly from solid to vapor, without passing through liquid phase. This preserves cellular structure and minimizes essential oil loss, creating dried herbs that closely resemble fresh in appearance and flavor. However, freeze drying requires expensive equipment and long processing times, limiting its use to very high-value herbs or specialty products, commanding premium prices. Regardless of drying method, temperature control is paramount. Excessive heat destroys volatile essential oils, causing loss of characteristic aromas and flavors, while also causing browning or scorching that makes herbs visually unappealing. Insufficient heat means extended drying times during which enzymatic degradation continues, and microbial growth may occur. The optimal temperature varies by herb species, with delicate herbs like basil and parsley requiring lower temperatures around 100 to 120 degrees, while hardier herbs like rosemary and thyme tolerate up to 150 degrees. Modern drying systems use multiple temperature sensors and automated controls, adjusting heat input and airflow to maintain target conditions throughout the drying chamber. Quality control during drying includes frequent moisture testing using either handheld moisture meters, giving instant readings, or laboratory methods weighing samples before and after oven drying. The target final moisture content balances several factors. Too much residual moisture allows mold growth and enzymatic activity continuing to degrade quality during storage. Too little makes herbs brittle and dusty, creating handling problems and consumer dissatisfaction. Most dried herbs target 8 to 12% moisture, low enough for shelf stability but high enough to maintain some pliability. After drying, The herbs undergo additional sorting and cleaning steps. The dried material passes over screens, separating leaves from stems, with different mesh sizes creating multiple grades. Vibratory screeners shake dried herbs across inclined screens, causing smaller particles to fall through while larger stems and intact leaves continue down the screen. Aspiration systems use airflow to remove dust and very light particles. Some facilities include destemmers, machines using rotating drums with projections that break dried stems away from leaves. The separated components are collected into different streams, with premium whole leaves commanding highest prices, smaller broken leaves selling as mid-grade products, and stems either used in lower-grade blends or composted. Further processing may include rubbing or milling depending on target product specifications. Rubbed herbs pass through machines with rotating paddles or rollers, gently breaking leaves into smaller flakes while avoiding creation of excessive powder. Ground herbs go through hammer mills or other grinding equipment, reducing them to fine powders. The grinding generates heat from friction, so mills often include cooling systems preventing temperature rise that could damage flavors. Each processing step is carefully controlled with samples tested to verify particle size distribution meets specifications. Sterilization is increasingly common to meet food safety standards, particularly for herbs destined for food manufacturing where even minimal microbial contamination is unacceptable. Steam treatment passes herbs through superheated steam for brief periods, killing surface microorganisms without significantly affecting quality. Ethylene oxide gas was historically used for sterilization, but environmental and health concerns have driven adoption of alternatives. Irradiation using gamma rays or electron beams effectively sterilizes herbs with minimal quality impact and is approved in many countries including the United States, though some markets remain resistant due to consumer concerns. Quality inspection of finished dried herbs includes comprehensive testing beyond moisture content. Color is evaluated using colorimeters, measuring precise color values compared to standards. Essential oil content is tested through steam distillation or solvent extraction with the oil content quantified. Volatile flavor compounds may be analyzed using gas chromatography, identifying and measuring specific aromatic chemicals. Microbial testing checks total plate counts, yeast and mold counts, and specific pathogens including Salmonella and E. coli. Pesticide residue testing ensures compliance with regulations. Heavy metal testing checks for cadmium, lead, and arsenic that plants can absorb from contaminated soils. Only herbs passing all quality and safety tests proceed to packaging. Packaging of dried herbs must protect against moisture, oxygen, light, and physical damage while maintaining the concentrated aromas consumers expect. Most retail dried herbs are packaged in glass or plastic jars, though flexible pouches are increasingly common. Industrial quantities are packed in multi-layer bags or fiber drums. The packaging process uses automated systems where dried herbs are metered into containers using volumetric or weight-based filling machines. These systems can fill hundreds of containers per minute with remarkable accuracy, using servo motors and load cells to deliver precise amounts. For ground herbs, auger fillers meter powder into containers, while whole leaf herbs may use cup fillers or vibratory feeders. Modified atmosphere packaging is employed for premium products, flushing containers with nitrogen gas before sealing to displace oxygen that would otherwise cause oxidative deterioration of flavors and colors. Vacuum packaging removes air from flexible pouches before sealing. Desiccant packets containing silica gel or other moisture absorbers are sometimes included to capture any moisture entering packages over time. Light-blocking packaging using opaque containers or amber glass protects herbs from photodegradation that bleaches colors and alters flavors. Labeling includes brand identification, product name, net weight, ingredient statement, country of origin, nutritional information, lot numbers, enabling traceability, best by dates indicating expected shelf life, and storage instructions. Many packages include recipe suggestions or usage ideas. Organic certification logos, non-GMO labels, and other marketing claims appear when applicable. Automated labeling machines apply pre-printed labels or print directly on containers, synchronizing with filling lines to ensure every package is properly identified. Storage before distribution happens in climate-controlled warehouses, maintaining cool temperatures between 60 and 70 degrees and low humidity below 60%. These conditions slow the gradual degradation that occurs even in properly dried and packaged herbs. Light exposure is minimized, as even packaged herbs benefit from dark storage. Inventory management follows strict first-in, first-out protocols, ensuring the oldest inventory ships first. The dried herbs can remain in storage for months or even years if properly packaged, though quality slowly declines over time as volatile compounds gradually diminish. Distribution channels move dried herbs from processing plants through complex supply chains to commercial and retail customers worldwide. Large food manufacturers purchase bulk quantities for use in seasoning blends, prepared foods, and restaurant supplies. Retail brands purchase either bulk herbs for repackaging under their own labels or finished packages from contract manufacturers. Specialty spice companies operate their own processing facilities or source from multiple processors, creating extensive product lines. The logistics involve trucking within regions and ocean shipping for international trade, with containerized shipping allowing efficient movement of mixed loads. Some high-value or time-sensitive shipments move by air freight, though this remains relatively uncommon due to costs. Pricing reflects quality grades, organic versus conventional production, and specific herb types. Commodity dried herbs in bulk quantities might wholesale from $3 to $10 per pound, while premium organic herbs can reach $20 to $50 per pound. Retail prices to consumers are dramatically higher due to packaging costs, distribution markups, and retail margins, with small glass jars of premium dried herbs sometimes exceeding $100 per pound when calculated from typical retail prices of $5 to $8 for small containers holding 1 to 2 ounces. Byproducts from dried herb processing include stems and low-grade material unsuitable for human consumption. These byproducts find uses in animal feed formulations where aromatic compounds may provide health benefits or flavor enhancement. Some material is composted and returned to agricultural fields as soil amendments. Essential oils extracted from herbs during distillation processes are valuable byproducts used in aromatherapy, natural medicine, cosmetics, and flavor extracts. Some processors operate steam distillation equipment specifically to capture these oils, significantly improving the economics of herb processing by monetizing material that might otherwise be waste. Culinary applications of dried herbs are vast and essential to cuisines worldwide. The concentrated flavors mean dried herbs are used in smaller quantities than fresh, typically 1/3 the amount. They excel in cooked applications where extended heating releases aromatic compounds into dishes. Dried oregano, basil, and thyme form the backbone of Italian cooking. Dried cilantro, cumin, and chili peppers are essential to Mexican cuisine. Herbes de Provence, blending dried thyme, rosemary, oregano, and lavender, characterizes southern French cooking. The convenience and shelf stability of dried herbs make them indispensable for home cooks and professional chefs alike, providing reliable seasoning year-round regardless of fresh herb availability. Nutritional value of dried herbs is often underappreciated. While used in small quantities, herbs are concentrated sources of antioxidants, vitamins, and minerals. Oregano and thyme contain exceptionally high levels of antioxidant compounds. Parsley provides vitamin K and vitamin C. Many herbs contain anti-inflammatory and antimicrobial compounds studied for potential health benefits. The drying process concentrates these compounds along with flavors, making dried herbs nutritionally dense even though serving sizes are measured in teaspoons rather than cups. Environmental impact of herb farming and processing merits consideration. Herb cultivation generally uses less water and fewer inputs than many commodity crops due to herbs' adaptation to Mediterranean climates. However, some water-intensive crops grown in arid regions require irrigation. Pesticide use varies widely, with organic operations avoiding synthetic pesticides entirely, while conventional farms may apply multiple treatments. The processing plants consume significant energy for drying, with fossil fuel-powered heating systems common, though some facilities have adopted renewable energy. Packaging waste from individual consumer-sized containers creates disposal concerns. Though this is common across the food industry, rather than unique to herbs. Sustainability initiatives in the dried herb industry focus on several areas. Organic certification has grown rapidly, with consumers willing to pay premiums for herbs grown without synthetic pesticides or fertilizers. Water conservation through drip irrigation and drought-tolerant herb selection reduces freshwater consumption. Renewable energy, including solar panels on processing facilities, reduces carbon footprints. Packaging innovation explores biodegradable or compostable materials as alternatives to conventional plastics. Fair trade certification ensures ethical treatment and fair compensation for farmers in developing countries where much herb production occurs. Looking at the complete journey from seeds planted in well-drained soils, where aromatic herbs flourish under sunny skies, through careful cultivation, managing water and nutrients to develop plants rich in essential oils, then precise timing of harvest at peak flavor when oil concentrations reach maximum levels, followed by rapid transport to processing plants, where modern dehydration technology carefully removes moisture while preserving the volatile compounds that make each herb distinctive, continuing through sorting and grading that separates premium leaves from stems, then into protective packaging that maintains quality through extended storage, and finally through global distribution networks that deliver these concentrated flavors to kitchens around the world. The dried herb supply chain reveals an industry balancing tradition with technology. The 4 million tons moving through global markets annually represent both ancient preservation techniques and cutting-edge food processing technology. The transformation from fields of fresh green herbs into jars of concentrated dried seasonings demonstrates how modern agriculture, technology, and processing capabilities have made flavors from around the world accessible to everyone. From small organic farms growing specialty herbs for farmers' markets to industrial operations processing 50 tons daily. From traditional air drying to sophisticated computer-controlled dehydration systems, the dried herb industry encompasses remarkable diversity in scale and method while serving the universal human desire to enhance food with aromatic plants. Thank you for watching this exploration of dried herb production here on AgriCraft. If you found this journey from field to spice rack informative, please hit the like button and subscribe to our channel for more farming documentary content exploring food processing technology and sustainable agriculture. Leave a comment below telling us your favorite dried herb or questions about herb cultivation and processing. Until next time, keep exploring the remarkable transformations that bring flavor to our tables.